Assalamualaikum and hi, my name is AQILAH binti SAIDON. My matric number is DE190044. So I will explain about the introduction of the project. For the introduction, a form of MOSFET, which is metal oxide semiconductor field effect transistor fabrication, is known as CMOS, which employ complementary and symmetrical pair of P-type and N-type MOSFET for logic function. The circuit design, fabrication, and chip performance are all closely related to one another and to chip performance as a whole. In order to generate the efficient design and to optimize the circuit with regard to numerous production characteristics, circuit designer must have a working knowledge of chip fabrication. The circuit designer must also have a thorough grasp of the function performed by the various fabrication masks and how they are utilized to define the various characteristics of the device on chip. In an N-type substrate, a P-well is formed, or vice versa, an N-well is formed in a P-type substrate. The PMOS transistor is generated in the N-well, which is built into the P-type substrate in the straightforward N-well CMOS manufacturing process that is described. Additional tabs of the same kind as the substrate may also be produced in the twin tab CMOS technique for device improvement.
Hi and Assalamualaikum. My name is NORASHIKIN binti NASARUDDIN. My matrix number is DE190039. For the CMOS design, the CMOS is a metal oxide semiconductor technology that combines both PMOS and NMOS technologies. About CMOS, CMOS stands for complementary metal oxide semiconductor. CMOS consists of P-channel MOSFET, PMOS, and N-channel MOSFET, NMOS. Become inverter and change direction current flow. And N-type turn into P-type when G equal to 0 on PMOS. For the PMOS is built over an N substrate, the reverse of the NMOS transistor. The condition is when it is off, G equal to 0, short circuit. When it is on, G equal to 1, open circuit. Majority carriers are holes. It conducts when the voltage is low and does not conduct when the voltage is high. How does a PMOS transistor work? First, the P-type transistor working is quite opposite to the N-type transistor. Second, NMOS will form a closed circuit with the source when the voltage is non-negligible. The PMOS will form an open circuit with the source when the voltage is non-negligible. Third, current flow from source to drain. Fourth, not short circuit when gate is on condition. And last, gate block the path between source and drain when G equal to 1, which is on. At low voltage, P-type is an on switch. At high voltage is the gate, P-type is an off switch. The body of the PMOS transistor is held at positive voltage. The source and drain terminals are reverse biased once the gate terminal is positive. When this occurs, there is no current flow and the transistor is turned off.
Good afternoon, Professor Maya, Dr. FARIZA. My name is ELVIS. So the phase transistor consists of two types. The first type is the NMOS and the second type is the PMOS. I will talk about the NMOS and Shikin will talk about PMOS at the following slide. The NMOS transistor consists of three important elements. So the first is the source, the second one is the drain, and the third one is the gate. So NMOS IV characteristic. In the cut-off region, the NMOS will be turned off. So no current is flowing through the channel, and the transistor acts as the open switch. And second, threshold voltage. Threshold voltage is the minimum voltage, is the minimum gate and source voltage needed to create a conductive path below the gate, which is a channel. So when the channel is formed, the MOSFET and MOS transistor is turned on. Next, linear region. Linear region is where the MOSFET will be turned on. So the channels is formed. So the VGS is bigger than VT, and the current is flowing from the from the drain to source. Saturation region is where the channel pinch off, as we know that the current IDS drain source is depends on the VDS, voltage drain source. So when the current IDS is no longer increased, so in the saturation regions, the channel pinch off and come to a saturation region. Next, transistor as a switch. When the gate is equal to 0, no current flow from the drain to source, as we can see that the transistor act as a open switch. And when the gate is equal to 1, the current flow from the drain to source, and there is a current flow, and the transistor act as a closed switch. Thank you.
I will explain about step-by-step microfabrication process from step 1 to step 10. Step 1 is first we select a substrate to serve as the foundation for fabrication. A P-type silicon substrate is chosen for the end well. Step 2 is oxidation. The selective diffusion of N-type impurities is accomplished by using SiO2 as a barrier that protects portions of the wafer from substrate contamination. Step 3 is growing of photoresist. The SiO2 layer is subjected to photolithography at this stage to allow selective etching. The wafer is coated with a uniform film of a photosensitive emulsion during this process. Step 4 is masking. This is the next step in the photolithography process. Using a stencil, create the desired pattern of openness in this step. The stencil is placed over the photoresist as a mask. Step 5 is removal of unexposed photoresist. By developing the wafer with a chemical such as trichloroethylene, the mask is removed and the unexposed region of photoresist is dissolved. Step 6 is etching. The wafer is immersed in a hydrofluoric acid etching solution which removes the oxide from the areas where dopants are to be fused. Step 7 is removal of whole photoresist layer. During the etching process, the photoresist layer protects the portions of SiO2 that are not affected. A chemical solvent, hot H2SO4, is now used to remove the photoresist mask. Step 8 is formation of N-well. The N-type impurities diffuse into the P-type substrate via the exposed region, resulting in the formation of an N-well. Step 9 is removal of SiO2. Hydrofluoric acid is now used to dissolve the SiO2 layer. And step 10 is deposition of polysilicon. A CMOS transistor's gate misalignment would result in unwanted capacitance which could harm the circuit. To avoid this, a self-aligned gate process is preferred in which gate regions are formed before source and drain regions using ion implantation.
Okay, for step 11, formation of gate region. Except two regions essential for formation of the gate for NMOS and PMOS transistor, the remaining portion of polysilicon is stripped off. Okay, and then for step 12, oxidation process. An oxidation layer is deposited over the wafer, which acts as the shield for the extra diffusion and metallization process. Okay, then step 13, masking and diffusion. Okay, creating region for diffusion of N-type impurities using masking process. Small gap are made using diffusion process. 3N plus region are developed for the formation of terminal NMOS. And then step 14, removal of oxide. The oxide layer is stripped off. And then step 15, P-type diffusion, similar to the N-type diffusion for developing the terminals of PMOS. P-type diffusion are carried out. Okay, and then step 16, laying of thick field oxide. Before creating the metal terminal, a thick field oxide is laid out to form the protective layer for region of the wafer where no terminal are required. And then 17, metallization. This phase is used for the formation of metal, provide interconnections. Aluminum is spread on the whole wafer. And then 18, formation of the terminal. In a gap of form after removal of acid, metal terminal are formed for the interconnection. And then 16, assigning the terminal name. Name are assigned to the terminal of NMOS and PMOS transistor. Okay, in conclusion, microfabrication methods which are started in microelectronics sector have now evolved into a sophisticated technique for the production of small mechanical component. This micro-manufacturing operation takes place using various microfabrication instruments. The purity of all micro-manufacturing process is critical. So, to avoid undesired contaminant that cause the system failure, cleaning should be performed at the start and conclusion of each operation. At each stage of preparation, different physical and chemical conditioning are used. Okay, that's all for us. Thank you.